Hi everyone, my name is Agam Mistry and along with my team members Jaimin Gaur and Mahi Patel will be presenting a project titled Cloud Security Implementation for Financial Service in AWS PaaS. The aim of the project was to design and implement a secure and scalable cloud infrastructure for financial organization using AWS platform. Finance systems store highly sensitive customer data, so we focused on the three critical security layers. First is IAM, Identity Access Management. Second is data protection, and third is network security. In this presentation, I'll cover how we handle the identity access control, and Jamil will cover later explain how we protect the data using the encryption. The slide 2 implementation of architecture. Here, this diagram shows the overall architectures of our project. It connects the multiple AWS components, IAM, AMS for encryption, and like VPC for network installation. Here we can see that our design follows the AWS share responsibilities model, meaning AWS manages the physical and infrastructure level security, while we are responsible for securing access data and configuring configurations within the cloud. This partnership ensures the both compliance and operational safety for financial data and the transactions. Here's my role. I am a setup. Here, my main responsibility was the identity access management configurations. IAM is like critical because it determines who can access which AWS service and under what condition. I begin by setting up IAM user role and policies to assign the least privileges necessary. To enhance security, I implemented multi-factor authentication for all admin and root users. We also used AWS organization to centrally manage permission across multiple accounts, ensuring that no one could make changes without proper authorization. Here we can see the list of users in the uh, screenshot. Here's the configuration for that. To secure the environment, I took the layered approach. First, I disabled the root account to eliminate the unnecessary privileges. Then I enable AWS Cloud Tail to log every actions and event across the cloud infrastructure. I also configured access key rotations every 90 days, which helps to prevent the long-term exposure of credentials. These security measures together made our access management system more robust and transparent and compliant with the audit requirements. Here we can see the dashboard of the AWS Cloud IAM. Here we can see that I open the MFA and which is activated. And here's the another screenshot in which I mentions the cloud tail logs. uh, the challenges which I like faces during the implementation of IAM. I faced like I mainly faced the issues while integrating SAML based authentication for single sign-on. At the times, users were locked out because of overly strict permissions. To fix that, I create user templates and the test access rule in the sandbox environment before deployment. Through this, I learned how to identify federation work in AWS, and especially how on-premises credentials can connect surely with the cloud resources. Overall, IAM played a crucial role in controlling every actions inside our AWS ecosystem. Now I'll handle it over to the Jamin, who will explain how we implemented data encryption and storage protection. Thank you.
Thanks, Agam. Hi, everyone. I'm Jaimin Gaur, and my part of the project focused on data security and storage protection. In the financial sector, data security is absolutely vital. We deal with sensitive information like customer identities, transaction histories, and account details. So, even a small data breach could cause major losses. Our objective was to ensure data confidentially, integrity, and compliance at all times. So here is my slide. And To secure stored data, I used AES 256 encryption for both Amazon S3 buckets and RDS databases. This means that any data stored in the cloud is unreadable without proper decryption keys. For data transmission, we implemented TLS 1.2 to encrypt communication between clients and AWS servers. This ensures that no one can intercept or view sensitive data while it's moving across the network. Together, these two layers, encryption and rest and in transit, form the backbone of our data security design. Here is AWS KMS and key management. For managing encryption keys, we used AWS Key Management Service. KMS helped us generate, store, and control encryption keys securely with AWS. I created unique keys for each environment and restricted access using IAM policies to make sure only authorized roles could use or rotate them. We also set a key rotation policy of once per year as recommended by compliance standards like PCI, DSS, and GDPR. Every key usage was logged, allowing us to trace who accessed data and when, which is very important for audits and legal compliance. And now I would like to tell about difficulties which I faced. During the configuration, I ran into some permission related issues. For example, certain objects in S3 weren't being encrypted automatically because the associated IAM roles are missing permissions to use the KMS key. To solve this, I created a test environment to verify each encryption configuration before applying it to production. I also manually validated every S3 object's encryption status using command line tools to ensure nothing was left unprotected, which approach helped minimize risk and give us complete control over the data encryption process. And now I would like to tell about the outcomes and key takeaways. In the end, our implementation met all security and compliance goals. We built a fully encrypted and monitored storage system that keeps financial data safe, even from internal misuse or external attacks. Through this project, I learned how AWS services, especially KMS, IAM, and CloudTrail, work together to create a multi-layered security framework. It was a great experience to understand not just how to configure encryption, but also how to align it with global financial compliance standards. That's all. Now I would like to hand over Mahi Patel. Thank you for listening.
My name is Mahi Patel. My ID number is 255 92407, and I was responsible for network security and monitoring part for our cloud security project. In our AWS setup, I designed a virtual private cloud to isolate servers in private subnets, and I also configured security groups and network ACLs to block any unauthorized traffic and ensuring that only trusted communication happens inside the network. To protect against the cyber attacks, I implemented AWS Shield Advanced for DDoS protection and AWS WAF to stop threats like SQL injection or cross-site scripting. Together, they provide a strong defense layer for our financial system. For monitoring and incident response, I set up CloudWatch, CloudTrail, and GuardDuty to detect unusual activities in real time. I also used AWS Security Hub to centralize alerts so we can quickly identify and respond to the security issues. During the process, I faced challenges like duplicate alerts and AWS conflicts. So I solved them using Lambda automation scripts, which help reduce manual work and improve system reliability. And I created clear organizational policy and SLs to ensure consistency and cloud security. They identify rule for backups and monitoring across all our team. So overall, This implementation strengthens the cloud infrastructure and ensure continuous visibility protection across our environment. Thank you.